I'm just going to quickly take you on a series of stories about fish and life and whatever comes to me. And then we're going to go upstairs and have a few drinks and snacks 2 floors up in the faculty lounge. So we have to get out of here before you get tired, and looking up is hard to do. So it's a tale of fish recovery, and it's been my honor to be part of this storytelling for a few years now. And it's my journey of discovery, and that is a 45 years study. And Bill Keller's here today. He saw me catch that first fish in 1980 on a secret lake somewhere north of here. And that same species is going to come in and be very important in this story, because the lake trout has made my career, and I've tried to do something good for it. In fact, it took me 45 years to figure out that I was giving it the wrong name. And in the last story, it'll be called the Lake Char. And I'll explain why that transition has happened and how important it is to recognize it now. And it's amazing, in 45 years, your appearance doesn't change at all. My mother always said, my boys always look good when they're holding a fish. And if you can't get them to smile, you can put a fish in their hands, and they're always happiest as holding fish. So I'll take you on this voyage of discovery. It was a ship that I showed you earlier. It's our research center story, the Cooperative Freshwater Ecology Unit. And it has these partnerships that that carry the weight of the voyage. The Ministry of Natural Resources and Fisheries, Forestry, NRCan, Ministry of Environment and Climate and Conservation now, and Natural Resources Canada are contributing now. And Laurentian is steering the ship with the flag at the back. So let's go and I always use the analogy of a boat, and that our teams are always paddling in the same direction. Some people paddle backwards, some aren't very good paddlers, but the boat is always going steadily forward. And we had 2 lovely boats over my career. One when I was a government scientist, and I loved being a government scientist. And then the second half of my career, I was a research chair at the university, and I loved being a research chair. And as Chris knows, I didn't pay attention to any bosses during all that period. It really didn't matter to me who was paying me. You pay me. So I enjoyed working for you. The first ship was the HMS Co-op unit, and it operated from 1989 to 2010. And the other ship in the convoy was the Valley Liverpool Lake Center, or the Lake Center, and it's operated from 2011 till present. We've had some rough times on this ship. In 1996, we were hit by the Mike Harris hurricane, and it washed away some of our best crew members for a while. We got them back, but it was a dangerous time. Nothing compared to recent years, when we were attacked by disease on board. COVID struck us, and when we were at our weakest point, we were attacked by a pirate called CCAA and stole our money, stole some of our people away. But the little ship kept going forward. Now we get hit with a big leak. A cyber attack gets us, like whoever even knew about cyber attacks when we started out on this voyage. But we're still going ahead. We're still moving ahead on this one. Because we had such a hardy crew. In the time that I've been with the ships, it's 600 to 800 people have come through the research center and through the student activities. And what a wonderful bunch there are. There's some of them here today that are in great jobs that they got their start with us. And I'm super proud of And they're paddling in the same direction as well in their new jobs, and that's a great accomplishment. The bottom picture was our 30th anniversary party we had down in Killarney, and our fish fries, and people came out from decades earlier to meet up with people again, a really loyal bunch of sailors. I've been fortunate to have wise counsel and officers and navigators in my life. My first, wearing the crown or the admiral on the ship, was the head of the Ontario fishery branch, Ken Loftus. I always loved to get to know the big boss in every organization. You always tell the big boss what progress you make. Don't ever tell them what failures you're having. And if they would only invest a little bit more, you'd complete the job. You're halfway across the voyage. It's not that you're just starting. You're maybe 3/4 way along. And all you need is the big boss to help you. And Ken was my big boss, and he was my first mentor, and he sent me out with instructions. I'm sending you to Sudbury for your first permanent job. And leaving, he was at Queen's Park, head of the big organization. And he gave me 3 demands on my time. He says, I'm hiring you as a biologist and a scientist. I don't want to see you in administration. And you have to do science. That's what I want you to do. So Ken, he's not with us right now, I have to admit. 45 years later, Ken, I've never read my contract. I've never read and opened the collective agreement at Laurentian. I've never been to Senate, not a single meeting. And I've only once, and begrudgingly, went to a union meeting. Ken, I did my best, and I have no idea how many eligible days of vacation I have. I have never known that. No one ever told me that. I've never submitted an overtime slip. So I'm proud to leave under those conditions that I didn't have any idea who I worked for. It was quite wonderful. His other one was you can do science and you can dig into something that you find really fascinating, but you might as well make it important to somebody else and make your work as significant as you can. And I'm hoping to convince you in a little way we did make a contribution bigger than our own fascination. You need collaborators, and Bill's here is my first professional collaborator. We wrote papers together. He became the co-captain of the other ships that were involved in the fleet. And you need multidisciplinary collaboration. You only know a little part, and you need to build that collaboration. And then most of us scientists, we don't know how to do anything. We need an engineer. We need a technician. You need to know how to stay dry in the wintertime. And Vic Lehman-Tyne, I was hoping Vic would be here tonight. He was my first professional technician. And you do wear felt pants in the winter. You don't wear jeans, Bill, I know, in the wintertime. And if you're anywhere in Northern Ontario and you have a Finnish engineer, you must have, and pronounce it correctly, a sauna in which to warm up after. Thank you, Vic, and all the subsequent engineers in my life that got me safely out of the bush. And then you need people that know how to outfit the ship and keep the resources flowing and keep the staff paid. Our first officer was Liz Bamberger, and she got the first ship safely to ground. And Karen Oman is here today, and we thank Karen for being my first officer in these rough waters. She weathered those storms amazing. And none of the supplies got stolen. We're getting them back. The pirates are being pushed off the ship, and we're moving ahead. And then there was the job of training the apprenticeships and the collaborators, the hundreds of kids that came for courses. And many of them came from other universities, and I really didn't care what university they were with. They were the Ontario Field Course program. They came from 16 different universities. And we have the Wall of Fame there at the Lake Center where the graduates are listed. So it was, and groups coming from other international universities. So it was wonderful to be in a training job because you're always training new crew members. They seem to jump ship every time we hit a storm. And they jump ship for great opportunities elsewhere. So training and workshops can be fun itself, and we've all participated in all kinds of them. Some of them are strange to me, like yoga practice, right? What captain ever needed to know yoga? But now we're into mindfulness and wellness and other things of that sort. So here was the big purpose for the expedition. Here's the Holy Grail. Why are we doing this thing? And it is to test the effectiveness of this gigantic experiment in Sudbury. Can you spend multi-billion dollars by the industries in town to make this phenomenal change in the air pollution in Sudbury? Can you bring us from the world's largest point source of sulfur and air pollution to being the model for pollution control on Earth? And as scientists, can you see how nature responds to it and think of other ways to restore? So the Holy Grail was around when and how does recovery happen if you give it a chance or you invest in it. Our treasure chest is our data. I think data was mentioned today. These are some of the captains or the owners of the data that have produced fantastic data sets that attract researchers throughout Canada to come to Sudbury to capitalize on the available data for 40 years. For instance, if you know Clearwater Lake down the road, there's Bree and Bill's data and Jocelyn's data that shows that we have one of the longest running acid rain monitoring sites on Earth, where you can show the effectiveness of clean air. This is without liming or anything else, just the effectiveness of clean air. And Nadia is sitting here. We didn't understand the microbial processes that triggered that as well. So we needed microbial scientists to join us to see why lakes recover on their own. And that is our treasure chest that we have to offer to the new scientists that are coming, and jobs are posted right now. We hope they'll know that we have data and are willing to share. The first story I'll tell is this famous fish. It's the Aurora trout. And Bill was part of the early discovery of this story, and this story was really important in the fight for clean air in North America. This fish that resembled the northern lights, the Aurora borealis, was lost from its home lakes north of Sudbury in a wilderness area in the Temagami area. Started to decline in the 50s from the pollution coming from Sudbury. And luckily, a fish management group took eggs and sperm from that and brought them to a hatchery in Hills Lake, where it stayed for another 45 years in a captive, while the original population was brought to extinction. The only 2 lakes in the world that contain this fish. And when we arrived, this was one of our signature projects, is can we get the Aurora trout back and living before inbreeding and other effects destroy the fish that are being held year after year into the hatchery. And for location, the Aurora Trout Lakes is well north of Sudbury and Wolf Lake and the municipality. And I couldn't help but squeeze in, everybody wants to talk regreening. I wanted to thank Peter Beckett for why these 2 images look so different as time went on. It's a much greener world than we started out, and if we had used 1978 from the satellite images, would be a far different world. But way up there at the top of the Aurora Lakes is the height of land, highest points in Ontario, and up there were these 2 little lakes that had the Aurora trout. So this crew, Ed Snookins, Lee Haslam, I hope they're online today, Rob Kirk in his long underwear, were some of the people that worked in the wilderness of the day to try to bring the Aurora trout back. And one of the projects eventually required that we neutralize the lake because we couldn't wait any longer for natural recovery to occur. And that became one of the big media impact stories of my career. We didn't expect, when we brought back the Aurora trout, that we'd be on the national news that night. We didn't expect the Globe and Mail to be there, the Washington Post. We thought we were quietly working on science, where the politicians of the day said, we just saved the Aurora trout. Send some people up there to congratulate us. We had no idea why they all turned up until we heard that the Premier had sent the planes up there to get on the news that night. And we struggled to get them to reproduce, hormone treatments, building artificial spawning sites, hoping something would happen. And lo and behold, they knew how to reproduce anyway. And a couple of years later, the first naturally produced Aurora trout in 50 to 70 years was on Ed Snooken's diving glove there. And eventually, it was delisted from the endangered species list. So that was a big breakthrough. Tale number 2. And it's science communication. You need a Dr. Dave to join our group. And his advice and wise counsel that you can fly all the way to the Aurora Lakes or somewhere remote, but we have a lot of municipal lakes right downtown. They need treatment too. Why don't we focus on urban lakes right beside the campus? We never thought of it. Something easy like the backdoor lakes, we should work on those. And you can see the impact of this study in every politician's presentation about Sudbury. They always mention 330 lakes in the city of Sudbury, the city of lakes. Now they're naming health units and financial offices, the city of lakes. And Dr. Dave influenced us to make that happen, to recognize the municipal lakes in the urban program. And again, a wonderful technician, Rod Sane, led the, and Rod has one of the great pictures of being so patient that he has a Grey Jay on his bun, ready to have dinner on top of it. And this is just a selection of some of the lakes in the urban area of seeing what the remarkable chemistry changes have been. So that's the pH recovering, and the red line is the line that we want all our lakes to get to. And over these years, the chemistry of the urban lakes has recovered. And the metal levels have declined right down to the provincial water quality objectives as well. And that's a partially effect of the smelter emissions, but also the land reclamation going around them. So the urban lakes are now some of our most productive lakes. And all of the damage in the local area, sometimes the most damaged lakes are now far away compared to the nearby lakes. And the fish have been recovering in the lakes itself. This is just a graph of what species lived in each lake. 10 years later, the graphs extend as more and more species colonize the lakes. And then the basis of the wonderful Jane Goodall film down at IMAX is loons come back. I never understood it. There's still people that hate fish, and they hate people fishing on their lake. But I haven't met anyone who hates loons yet. And you can't have healthy loons reproducing unless you have fish, so you can win them over if you can get enough food in the lake to feed a loon. And it looks like it takes, the chemistry will improve, you got to get the fish back, and then the loons come in. And that's the basis of the story on IMAX playing at Science North, where we had the honor to work with Jane Goodall on the story of the recovery of the loons. And a new one is coming out for permanent display at a Dynamic Earth soon, and that will feature the story of Lohi Lake, and which was the Finnish name for salmon. I was just talking to our president Sheila Embleton, and she loves language and words. And she said, Loughy Lake is salmon. You could make the story, why don't you split the word in half, low and high? You can make the low part of the story the damage period, and then the high period at the recent recovery. I thought, good. I need to be a university president before I could think of such a good idea. I want to thank past colleagues that worked with us on the fact that there's fish in the lakes in the urban areas, but they're also super safe to eat. And Nelson and Uwe, who we both retire on the same date, I guess, July 1st, and they found out that some of the contaminants that came in the local area protect us from the mercury that causes the fish to be inedible. So if it doesn't kill you, it makes you strong. In sailor terms, hair of the dog that bit you. So that's a maritime expression. You feel better the next day by having the same whiskey that put you under the table the night before. That work has been taken over by some wonderful young people. One of them is standing over there, Adam LePage. And one of them I'm going to visit on Wednesday in Florida, Gretchen Lescourt, who's a big shot now, and she has a giant lab and all the facilities we never could have provided for her. But she claims she got some advantage from us. And it's nice to go visit her and tell these stories with her. One of the unusual things is that water people worked alone and fish people and tree people worked in their little silo. Sometimes we never talked to each other. We started to hold workshops and conferences together and started to understand the land-water linkages. And there was marvelous relationships between healthy land and water that we didn't understand. That if you neutralize and improve the land or grow trees, you can actually protect the lake much more quickly. And in fact, trees make lakes colder and more productive. And they feed fish that grow up in lakes. 70% of their body is made of carbon that originated in trees in one of these studies. Now that was a study that I was working with this superstar brainy head from Cambridge University, Andrew Tanizak, and he could see in all the data some marvelous patterns that very few other people are able to see. And he was able to build this story, and we were able to publish in one of the great journals of the world, Nature Communication. And it took 3 revisions, 210 different questions that had to be answered, finally came out, published after 4 or 5 years, and lo and behold, we got scooped. Just as we came out with a paper that was called Forest Fuels Fish, some kid's author published in the gray literature this darn paper that tells the story even better than ours. And this book came out our same year called Trout Are Made of Trees. And I like this one better than our paper. This is really well told. And the illustrations are easy to see that, you know, the leaf falls in the water, the bugs grow it, they start to digest it, the insect eats the bugs on the leaves, the fish eat that. That's what our paper said. They didn't even cite our paper. So I'd like to wrap up this talk before we go for drinks and eat something with a tribute to my supervisor, who looks and acts like me, and that's what you want in a supervisor. And he taught me the difference between trout and char and why it's important to know where you're from. Some of the debates we might have on immigration could think about this. Where does culture and behavior and life start? Often it's in the distant past, and you're not able to control it with rules and regulations very well, or naming. David Noakes was a brilliant PhD supervisor at Guelph, and he was so smart that he filled most of his life just collecting trivia, because he could do his day job so quickly that he got into collecting electric typewriters and Mama and Papa records and all manners of cooking recipes to keep himself occupied. And I quite like that. I quite enjoy that. So David and Pat welcomed me into their family as an older student who needed a PhD, and Chris brought 2 kids to Guelph to get that degree, and the Ministry of Natural Resources sent me off with half the salary to pay for that, and we had a grand time becoming students again. But when we got there, the kids realized we were from Sudbury, and there's no water in Guelph. There's no place to go swimming. So I insisted that my supervisor has a lovely yard and pond, so we took up camping in his backyard on weekends. And here's a picture of Robert, you're underwater, and Daniel's on the surface, while we're camping at my supervisor's backyard, using his washroom, and standing outside his door waiting for breakfast, because he in turn finally got me graduated and organized various gifts for me. And my daughter Bonnie was born in Guelph, and Kristen introduced her to everybody. And for my graduation present, I got this plastic flamingo. But he enjoyed taunting the system, much like I do. On the day I graduated my PhD, he nominated me for the Alumni Award, which should wait 10, 15 years. But he just wanted to know whether he could write a good enough proposal to make them accepted. And they did. So I was stuck then. I would have to do his bidding. Anytime he had a challenge that I had to make, and whether it was finding the Mama and Papa records, he had the hooks in me, and 3 times a year there was something I had to do. On the day he heard that Margaret Atwood's birthday was in Sudbury, he knew what he had to do. In came a package from David Noakes, now at Oregon State University, where he became a big shot there as well. And he started a cooking class for his graduate students as well, and organized massive things for Oregon State. But he got into the football team issues and kept the stats for all the football stuff. And he asked me when I opened this package, I know that Margaret Atwood would be there in Sudbury on this particular day. I'm going to be in the faculty lounge in Oregon State. Can you send me a picture of Margaret Atwood wearing our football t-shirt for the Oregon Beavers? I did. And he has loved me ever since. His students can deliver when asked, can get things done. And I had to not tell a full truth to get this done, but Margaret Atwood's memory isn't complete of who David Noakes was and why she should do this for him, but it worked out. He wasn't a publisher after all. He was a publisher of a fishery journal. It wasn't really a poetry book. But it was close. So the last little bit is David Noakes' belief about biology and your place in this earth, in perspective of where did you come from. And so when he introduced me to this species, the lake trout, he said, where did it come from and when? Well, it came 3 million years ago. It separated from other members of that species or that genus as a Salvelinus, that is closer to an Arctic char and certainly is not a trout. And it is an ancient animal who's out of place. You should think of the fish that's in your hand as if you're standing at the Toronto Zoo and looking at this polar bear and thinking, I'm looking at polar bear habitat. That's not polar bear habitat. That's the Toronto Zoo. That is not where polar bears come from. And where does the dogma of science come from? Usually comes from universities that are very close to their study site. The dogma on science on the lake trout comes from the University of Toronto because their field station is either in the Great Lakes or in a very close by field station in Algonquin Park. So as far as a know-it-all U of T prof, all lake trout look like the lake trout they study in their backyards, either at Algonquin, but where did it come from and who was it before it got to that lake? That was David's. Tell me the evolutionary story. Tell me where it came from and who you are based on your history. Salvelinus namakush, and we didn't even know this when I started out. I inherited a fish that the textbook, The Fishes of Canada, came out and said this is one of the best studied freshwater fish in the world. And you're to use it for your research projects on acidification. Well, that's clear. Everything is already known about the fish. I just have to apply it to a man. Well, very little is really known about the fish. The first is we are only looking at one type or form of lake trout, the one that we see in Ontario. The other forms that are so diverse and look like birds and big-bellied creatures, they look very different in other parts of the range. And in fact, it's now considered the most diverse of any vertebrate, rather than the same single fish that it was. And that's all been discovered when you look at great depths in big lakes like Great Slave and others that have other layers of evolutionary pressure on them. So first, I learned we're only looking at a tiny piece of the distribution of this animal. And then with David's insight, you're looking at something from the past. This isn't a modern fish. You're looking at an Arctic animal that's stuck in a pond here. And it's more like a polar bear or a narwhal than it is many of the fish you're talking about. It's like a polar bear or a northern animal. It's long-lived, lives to 80 years. It's large-bodied. One of the largest freshwater fish, lives maximum size over 100 pounds. It doesn't mature in some settings till it's over 20 years old. It'll eat anything. And it doesn't take a chance on the future with tiny eggs. It invests in the present with large eggs. If you're living in a harsh environment, that's what you do. So I started to think about this fish. I'm working with polar bears. Everybody wants to be part of the polar bear crowd. And the habitat we're looking at today is not the habitat from which it came. This is the traditional habitat of the lake char. It lives on the edge of the ice. It lives under the most extreme environments where the glaciers meet the land. And it made its way back into the lands and waters we see today after the glaciers was treated. It's a glacial river fish. It's not even a lake trout. It's a riverine animal that lived for 1 million years as a big predator in the ancient rivers. And so you should be looking at the conditions of the fish through the eyes of those 1 million years. Where did it come from? And what behaviors come from those ancient pasts? So we know that 18,000 years ago, and Joe had a great image of this, the area was covered. Now when you look at the lake char distribution, those aren't lakes anymore. Those are tidal pools where the ice pulled away, and rather than starfish caught in the pools, there was poor little cold water lake char stuck in there waiting for the ice to come back to be free again? How long do I have to stay in Opeaugo Lake before I can be a riverine char again? Who put me here? And so if you view them as tidal pools, temporary, very young waters, you start to think of them different. They're not that's not their habitat at all. They're just in a motel room waiting. So of the skills and traits that their evolutionary history gave them, what persists to this modern day? What are the traits in this animal that might be useful to face the big challenges we have, like climate change and other challenges this creature faces? So the four that I've chosen here is, if you're living that close to ice, 0 degrees, even living under the ice in many cases, how do you manage thermal regulation under such extreme temperatures? Idoparity means reproducing every year and taking a chance that one year will be a good year. How do you reproduce for as long as possible in case it happens to be that you can successfully reproduce? And what do you do if you have to move? And what do you do when the food the hatchery manager doesn't have in the bin is not available? So if you look at David and told me, look it through the lens of where did it come from and what are the traits that still live today, and see if you can find any evidence that they still function. So if you're going to do a big experiment on that, you need an analog. You need a new place where you could test the idea of how does a fish live under the toughest and worst conditions where you have no food, extreme environments. Here I was lucky to get this picture. This is a very old picture of indigenous people following the glaciers. I didn't know they have Kevlar in those days. But people came at the same time as the lake char. So people and the lake char were one and the same. They came together and they interacted together. And it's important to think people are part of their lives and they are part of they've been a nutritional source for people as long as they've existed in this area. But that's the habitat of lake trout, not the one that we think of as Panage Lake or something. So we actually have a place where we could test this. Where would there be a place that destroyed all the biota, where it eliminated the productivity of the area, and started clearing again with some empty systems? Aha, we could see that could be Sudbury. And yes, indeed, Sudbury is a place where we took these tidal pools and we wiped out everything in them, brought them back to just distilled water almost, very little productivity, perfect place for a lake char to see, can I make a living there under the worst of conditions? And what if I run an experiment where the conditions start to change as the years go by? Well, why don't we get the industries to spend $3 billion to clean up the lakes and then run the experiment again, fast forward. And they are really young systems. If you look at the Killarney lakes and these are lakes that are only about 4,000 years old. The water levels are just dropping away. 4,000 years ago, the Crack was just underwater in Killarney. These are simple systems. The tidal pool is very young. And how does this ancient fish make a go in such a system? So we did the big experiment. We had 100 dead lakes where the lake char had been destroyed. Nice sample size, good replication for the experiment. And then we took 500,000 char of various sorts and we planted them under different experiments. And we ran the experiments to see, are there any of your old traits that are still useful today? The first one was temperature. How do you deal with finding the appropriate temperature? So we put a data logger inside a fish, careful surgery, nobody died, everybody was fine, and let them live out their life for a year, recording what's important to a fish is what is my core body temperature. So what runs my physiology? And this is known to be the most cold-loving creature among our freshwater fish. And it's good at finding cold water. It's very good at it. Put it in a lake where it's 25 degrees on the top and 4 degrees on the bottom, and look at the temperature inside the fish. And you see in May it keeps its body at 6 degrees. Summer comes and it starts to fluctuate, that it's making trips up to feed and looking for food, but it's big enough that you can spend a long time in warm water and not change your body temperature. But then a special day happens in October, and that fish goes right up to 14 degrees. But nobody else is up there. Looking to spawn is the one day where I've got to do, it's good to sit on the bottom of the lake, but I can't make more lake char this way. I've got to go up into the warm water, have a hot time together with somebody else, and there wasn't anybody there. So it came back down, stayed 2 days, went back up, and there was somebody else there to court and spawn with, and it stayed there. That is a beautiful image of the inside temperature of a lake char doing its work of finding the temperature it needs to run its physiology. And we discovered it can do it in the oddest way. If it can't find it on the bottom of the lake, it can search out groundwater springs. And this one was in less than a meter of water in a hot lake. And the big lake char would scare out the little char and get into the spring. And it's just like the Finnish people jumping out of their sauna into the ice. They seem to be able to tolerate that. But the lake char goes into the cold water, stays there as long as it can possibly, goes out to feed and goes back in, and suffering bird damage on their back, living in shallow water. The amazing adaptability of this creature that was described to be so sensitive it couldn't tolerate change. And then longevity. This is the finding that made my career. Bill and I were working on a lake at White Pine Lake that was getting better, or experimenting with different fish, the ones with the tags on them in the bottom. And all of a sudden, a lake that had failed to reproduce for decades, where we had 1 or 2 adults that had survived all this time, trying to reproduce every year, all of a sudden there were young fish in the lake. And this became the basis of our paper in Nature that went to the discussions in the US Congress that said, don't give up on an ecosystem. Put your efforts on pollution control. The ecosystem can come back. Don't give up on it. This was a very important paper that affected our career. Now, you might not know what a 1+ is. There's a technology. Fish spawn in the fall, and they emerge in the spring as little fish. So you give them a plus. Now, a good way to illustrate that is, this is my grandson, Johnny. Now, this is when he's 1+. So you can see he's past not yet his 2nd birthday. And Victoria, she's a 4+ in this picture. So I don't know how I introduced these pictures of the grandchildren into the talk, but it just helps you in aging fish. When you think of fish ages, they're related to that naming system. The mobility, we were managing the lakes one at a time. The ministry had a management plan for this lake and that lake, how many fish to put in there. And the fish didn't read the management plan. When conditions weren't perfect in this lake, they swam through tiny little outlets, big fish, going to where they needed to find the habitat and Sarah's here today. One of the most exciting findings for not too long ago is the fish from Chiniguchi have moved down the Wolf Lake chain and now colonize with natural reproducing populations the lake south of that area in the old growth forest area. They also started to surprise us. Lake char can't possibly live without all the things that the textbook said. They have to have small fish to eat. They have to, it's a pyramid. But if you don't have anything to eat, you have to eat whatever you can. And Kim knows, because she had the microscope counting all these things. We found that they could make a living on the tiniest invisible little micro invertebrates, the Chiabras, and could thrive if they were under their ancient conditions, were no competition, nobody else fighting for food. Give me whatever food we have and I'll make a go of it, is their approach. DOC is the color of water. And we found that trees make tea. Anybody seen a tea bag where you pour hot water over it, makes the thing that comes out brown? That's how you make dissolved organic carbon. Organic matter releases color into lakes, and color is a natural sunblock that prevents ultraviolet radiation from destroying these little tiny organisms. So as the forest came back and the color came back to the lakes, these little organisms could survive, and the char said, if there's no big fish, I can make a go on those alone. So we saw this incredible omnivory. The only thing they couldn't deal with and aren't able to deal with in the climate focus ahead is warm water competition. They can't deal with southern species filling up the range that they live in. So they can deal with all this hardship, but you put bass into a lake or introduce other species that compete for food, 77% decline in the lake char in such lakes. I just want to leave it there, and we'll go up for drinks and juice. But I want to thank everybody that contributed over the years. These were wonderful times we had together in the shore parties and in class. I always made my students in seminar class dress up and pretend that they're famous authors. Like Oliver Sacks is there in one of those locations, and Charles Darwin came to class several times. But and Halloween parties were great at the Lake Center. And I want to thank what the future holds for us. We're advertising jobs for the co-op unit right now. And she's in the room somewhere. We have a new captain. Jackie Litzkes has taken hold of the And whatever the new university is, I don't think anyone is against the idea of clean water now and forever. So I hope this mission statement ends up in the strategic plan or whatever plan. And if so, I think a focus like this will offer a bright future. So thank you very much.
John, thank you so much for that lecture and sharing your stories. And we know we can still find you. So although you're retiring, we think that you're going to become one of those professor emeritus that we can always call on for your. Well, we want not all the time, but I mean, I think what I heard from this and perhaps others is it's really about collaboration. It's about community. It's about connection. And you really created that. I mean, you mentioned Dr. John Gunn, and people know who that is in the community. Students know who that is. When you have people coming back years later to be part of your cohort, it's because you created that culture of caring. And we need more of that at this university. And thank you for continuing to bring that culture of care and to make a community. Do you want to say anything else, Joy?
Thank you.
Sure. Just when, you know, I was listening to your talk, John, and it really struck me that you have something very important in common with the fish that you've been studying. You don't give up.
No.
And that has led to the Valley Louisburg Lake Center. It's led to a roadmap for us when we're trying to replicate what you've built there in terms of collaboration, what everyone builds, yes, in terms of collaborations between universities, government, and industry. And I would like to thank you for that. And thank you for inspiring and continuing to inspire us as scientists, everyone in the room, the community, and most importantly, our students. Thank you.
Small gift in celebration of your service to the cause of environmental recovery from your colleagues of Laurentian University.
It's 2 floors up. We'll see what